a couple more examples of factoring quadratics where they're in the form ax squared plus bx plus c, and we now are looking at cases where a is not just equal to 1. So let's look at this example. 2x squared plus x minus 21. The first thing we're going to do is identify all of our coefficients and constant. A equals 2. B equals, invisible, 1. And C equals negative 21. Now I'm going to think about what numbers multiply to get A times C. So let's figure out what A times C is first. A times C equals 2 times 21, times negative 21, which equals negative 42. So I'm looking for two numbers that multiply to get 42. So we're looking for factors of negative 42. And we want them to add up to be, it should be B, which is 1. All right, factors of negative 42. Oh, yeah. Well, 2 times 21 definitely don't add up to be 1. Even if one of them is negative. Is 42 divided by 4? No, it's 42 divided by 3. Yes, that would be 30 plus 12, so 14 and 3. Our result is positive 14 and 3. Positive 14 times negative 3 definitely does not equal positive 1. 6 times 7. 6 times 7, there we go. And if we make 7 positive because it's bigger, then our result would be positive 1. Excellent. 6 times 7. Well, negative 6. Okay. So I'm going to go ahead and write this. And because when I'm looking at the 2, here's a little clue as to what order you're going to write your 2 parts of this positive x term. I know that 7 and 21 have a common factor. So what if I put the 7x near the negative 21 and the negative 6 near the positive 2, because those also have a common factor? Let's do that. So I'm going to rewrite this as 2x squared minus 6x plus 7x minus 21. And again, I've not changed the value because negative 6x and positive 6x would combine to get positive 1x. Okay, now I'm going to group these together, right? In fact, I might even write that on the next line. 2x squared minus 6x plus 7x minus 21. Okay, now I'm going to figure out what I can factor out of each of these pairs of terms. So here I have a binomial, 2x squared minus 6x. What's the greatest common factor of these two terms? I know I can factor out an x. And I also know that between 2 and negative 6, 2 is the greatest common factor. So I'm going to factor out 2x. And that leaves me with 2x squared divided by 2x would just leave me with x, right? You can multiply them together, you get that. 2x times x is 2x squared. And then negative 6x divided by 2x will leave me with negative 3. X divided by x is 1. And negative 6 divided by positive 2 is negative 3. Okay, over here, I'm going to factor out 7. And I had kind of noticed already that 21 and 7 both have that common factor of 7. So let's factor out a positive 7. 7x divided by 7 is x. And negative 21 divided by 7, what do you know, is negative 3. And sure enough, we have this binomial in common. Right? We now turn this into a monomial times x minus 3 and another monomial times x minus 3. Now we can write those as 2x plus 7 times x minus 3. Again, this line here is our first term of our first binomial multiplied by the second binomial. And this line here is the second term of our first binomial multiplied by our second binomial. So that turns into this. And of course, you could multiply these two together to make sure that your work is correct. I'm going to move on to another example. Here's a case where you might have to do one step prior to what we've just done. Miss Van Kirk, that is not quadratic. There is x cubed, that would make it a cubic polynomial, not a quadratic. What is going on? Well, remember way back when we were factoring out monomials from polynomials? That's what you're going to do first. So actually the 0th step, if identifying all the constants and coefficients is the first step, then the 0th step is to factor out the greatest common monomial. So if I look at all three of these terms, first of all, you might notice that, well, 6, 9, and 3, those are all multiples of 3. I could factor out a 3. And then you might also notice that if all of them have at least one x in them, that I could also factor out an x. So let's do that. We're going to factor out a 3 and an x. And I'm going to rewrite this as 3x times whatever's left over once I divide out that 3x from each term. 6x cubed divided by 3x would be 2x squared, right? 6 divided by 3 is 2. X times x divided by x leaves me with 2 x's being multiplied by each other, or x squared. 9x squared divided by 3x, well, 9 divided by 3 is 3. And x squared divided by 1x would just be x. And then 3x divided by 3x is 1. Now, inside these parentheses, we have a quadratic. It's in the form of ax squared plus bx plus c. And we can follow this process that we did previously. So we're not going to forget this, but we're going to concentrate on what's inside here. Okay, so now I look at this, and now I'm going to identify A as 2, B as 3, and C as 1. A is 2, which is the coefficient here. B is 3, the coefficient in front of x. And 1 is our constant. And now, of course, I'm going to figure out what A times C is. And that's going to be 2 times 1. And that's going to be 2. And then I'm going to ask myself, what are the factors of 2 that add up to 3? Oh, 2 times 1. What do you know? 2 times 1 add up to be 3. So I'm going to keep that 3x, I'm in a little space here, 3x. I'll put this in brackets just so that I can see that I'm kind of doing some work inside there. And I'm going to rewrite this as 2x squared plus 2x plus x plus 1. Okay. So 3x became 2x plus x. 2x plus x is 3x. And now I'm going to group. So I'm going to rewrite 3x. I guess I didn't really need it in brackets yet. 3x times, now I need brackets though, because I'm going to do in parentheses 2x squared plus 2x plus x plus 1. All right. So here I have 2x squared and 2x, and I notice that I can factor out a 2 from both of them, and I can factor out an x from both of them. So now I'm going to rewrite this as 3x times 2x times x plus 1, because 2x squared divided by 2x leaves me with just an x. And 2x divided by 2x leaves me with 1. So then this one, I can't really factor anything out, right? But there is an invisible coefficient of 1 here, or you could think about factoring out a 1. I'm going to make it visible to make it easier to do my next step. Let's scooch this up. So I'm going to write this as plus 1 times x plus 1. Because these two binomials are the same. Now I can see I have my first term and my second term of my first binomial, and then x plus 1 is going to be my second binomial. So I'm going to rewrite this as 3x times 2x plus 1. That's the first term of the first binomial and the second term of the first binomial. And then I'll write x plus 1 as my second binomial. And I don't really need these brackets anymore. I can just rewrite my final answer as 3x times 2x plus 1 times x plus 1. So there it is. If you have a number in front of the x squared that's not 1, you first really do need to look to see if there's anything you can factor out of all 3 terms. In this case, I had an x, but even if it was 6x squared plus 9x plus 3, I could still factor out that 3, and that would be the way to get to the complete factorization. If you don't see it in the end, and if you did end up with, for example, let's see, if you ended up somehow, if you got to 6x squared plus x plus 3x times x plus 1, then you might look at this binomial and notice that you could factor out, oh, you can't really that. There you go. So say you did this, you managed to factor this problem into 2 binomials like this. But this binomial still can be factored further. So you can still factor out that 3x from here and end up with 2x plus 1. So even if you don't see that common factor here, take a look for it, make sure there is no common factor, but if for some reason you miss it, take a look at your final answer as well, because if one of your binomials also has a common factor that you can factor out, you need to do that too to complete the factorization. We're trying to get this down to the most simple parts possible.